Hello everyone. So let's continue where we left off last time. So let's see question 29. So I'll discuss about it, and I will actually mention the idea as well. So you can actually use question 28 to prove it. So prove that just bring the charger. Prove that a positive integer is divisible by 9 if and only if the sum of its digits is divisible by 9. So you can use a similar technique right away, because we even had to extract the pieces of information where we had to change the 9 into a multiple of 3. So you can just keep it like a 9 like that, and then you can use the same idea as above. So let's look at the next question. If a1 to an are integers, not all 0, then their greatest common divisor GCD is the largest integer D such that D divides AI for every I prove that there exists integers UI such that you can express D as a linear combination of all of the AI using the UI. So what you could do is that you could consider S to be the set of all the linear combination of the AIs, such that you're considering the positive elements, or you could just consider all the linear combinations where all the xi's belongs to z. Then this has at least one positive element, because let xi to be ai. Since not all are 0, you have that a1 squared plus an squared, which is a1 x1 plus an xn, that is strictly bigger than 0. And so it has at least one positive element, so we can apply the well-ordering axiom. Is the minimum element, minimum positive element, minimum positive element of S and you can apply the same reasoning as before and show that T is, so by analogous reasoning, T is the greatest common divisor of A1 to AN. So let's show that. Yeah, so let's show that. So first of all, we can argue for AI, so apply the division algorithm for T on working on AI. So you have a quotient as well as a remainder. Where this Ri is bigger or equal to 0 and less than T. So in particular, you have Ri is AI minus TQI, and you can replace T as a linear combination of those AIs. Then you have A1 U1 plus AN UN multiplied by QI, and then this is AI, or let's write it differently. So this is minus A1 multiplied by U1, or it's A1 multiplied by minus U1 plus blah 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 AN multiplied by minus UN all multiplied by QI. But we don't have the I will yeah, sure, then that is thinking about a detail, but I'll leave it towards the end. So then that's plus AI. So this is A1 minus U1 plus AI minus 1 minus UI, plus you can factor an AI, and that would be minus UI plus 1, and then that's plus AN minus UN. So then RI is a linear combination of the AI. So then you get the following. You get that RI is in S, so it must be 0 because it is less than T, and therefore you get that T divides each of the AI for all I. So we get our result. All right. So there's a couple of exercises left. I will show that in the next few videos, and then we'll move on to prime and unique factorization theorem. See you guys.